In this lesson, you should learn to express a triple integral as an iterated integral, set up a triple integral that will solve for the volume of a solid, and evaluate triple integral. Given a function f of x, y, z, its triple integral over a solid S in the 3D space is as shown, where dv can be written in 6 different possible ways. So that is, there are 6 different possible orders of integration, and whichever order you do will depend on the function and what you feel would be the easiest, of course. So you should get the same answer regardless of the order of integration. Now let us first look at the triple integral of the function f of x, y, z over a rectangular solid as defined by the solid S, which is the set of all points x, y, z, where x is from A to B, y is from C to D, and z is from E to F. So from the previous slide, since dv can be written in different ways, so again, that means we can do different orders of integration. We will now obtain some iterated integrals that will solve for the triple integral of this given function over the given rectangular solid S. Okay, let's try the first order of integration, dz, dy, dx. Okay, similar to evaluating double integrals, this order means we have to evaluate the integral with respect to z first, so followed by y, and then lastly with respect to x. As for the bounds, we integrate the function with respect to z over its value na covered ng given rectangular solid S. Thus, we have integral from E to F when we want to evaluate it with respect to z, and then the same goes with integrating with respect to y. Thus, we have the integral from c to d, and then the integral from a to b for integrating with respect to x. Okay, let's try another one. Okay, let's integrate the function with order of integration dy, dx, and dz. You can pause this video to try complete this iterated integral on your notes. Okay, you'll get, with respect to y, our bounds is from c to d. With respect to x, our bounds is from a to b. And then lastly, we have e to f. Now let's have an example. Evaluate the triple integral of 6x y squared z cubed dv over the rectangular solid S containing the points x, y, z, where x is from 1 to 2, y is from 0 to 1, and z is from 0 to 2. So to solve this, we have to write it as an iterated integral. So in this example, the order of integration is dx, dz, dy. And now we have to get the bounds for this iterated integral. So for dx, look at the solid S. So the values of x is from 1 to 2. So the bounds for this part of the integral is 1 to 2. Now integrating with respect to z, so our bounds would be this one. So from 0 to 2, hence, so we write it that way. And lastly, for y, so we have the values from 0 to 1. Hence, this is the iterated integral of the triple integral given in this order of integration. At this point, we are now to evaluate the triple integral using the obtained iterated integral. We start with the innermost integral, hence we evaluate first with respect to x. So that means other variables present will be considered as constants. And using basic rule on integration, we get 3x squared y squared z cubed. Further evaluated from 1 to 2, we will get 9y squared z cubed. And again, we evaluate the inner integral first. Thus, we get the integral from 0 to 2 of 9y squared z cubed, treating other variable as constant. Hence, we will get 9y squared z raised to 4 all over 4. Further evaluated from 0 to 2, so we will get 36y squared. And now we are left with a simple integral, so we can factor out from the integral the constant 36. So we will have the integral 36 times the integral from 0 to 1 of y squared dy. So again, using a basic rule on integration, we can easily evaluate this to 36 times y cubed all over 3 evaluated from 0 to 1, hence we will have 12. So this means that the triple integral of the function 6x y squared z cubed over the rectangular solid S given is equal to 12. Oh, ikaw naman. Evaluate the triple integral of the function 8xyz over the given rectangular solid B by expressing it as an iterated integral. You can pause here and try to answer this item. Here is one of the solutions for evaluating this triple integral. You can pause here and check your answer. We now move on to the more general three-dimensional regions or solids other than the rectangular solid. We begin with the given solid shown. The solid S is bounded by the graphs of z equals g sub 1 of xy and z equals g sub 2 of xy. Usually, if the solid is oriented this way, a region D, as shown in the illustration, is projected on the xy plane. And we follow this order of integration. dz dA, where dA can either be dx dy or dy dx. So, the triple integral of a function f of xyz over this solid can be expressed as an iterated integral with order of integration dz dA. As for this illustration, dA is dy dx. So generally, the bounds on the iterated integral with respect to z is from g sub 1 to g sub 2. So this is over the solid for z. While for the bounds for y is written as a function of x, the bounds we have is h sub 1 of x to h sub 2 of x. This is a function of x, so this is over a region D on the xy plane. And lastly, the outermost integral is evaluated over the values of x, say a sub 1 to a sub 2. Let's have a solid oriented as shown in the illustration. The solid S is now bounded by the graphs of x equals g sub 1 of yz and x is equal to g sub 2 of yz, and the region D is now projected on the yz plane. Then, the triple integral of a function f of xyz over this solid can be expressed as an iterated integral with the order of integration dx dA, and dA can either be dy dz or dz dy. And in this discussion, we use dy dz. So the bounds over the solid for x for this iterated integral is from g sub 1 to g sub 2. Then for over a region on yz plane is h sub 1 to h sub 2, and lastly over the values of z is from c sub 1 to c sub 2. And another orientation for the solid is as shown in the figure. So now the solid S is now bounded by the graphs of y equals u sub 1 of xz and y equals u sub 2 of xz, and the region D is now projected at xz plane. Now it's your turn to write the triple integral of f of x, y, z over this solid as an iterated integral. Let's have an example. Set up the iterated integral of the triple integral of 2xyz over S, where S is a tetrahedron bounded by the plane 3x plus 3y plus 2z equals 6 and the coordinate planes as shown in the figure. To answer this example, first, we shall write the triple integral as an iterated integral with order of integration na gusto nyo. For this example, we do dx, dy, dz, in order of integration. So that means our solid S is oriented this way. So we create a rectangular prism so that the bounds of the solid for x is the yz plane and the given plane 3x plus 3y plus 2z equals 6. For the yz plane, we have the equation x equals 0, and for the given plane, we shall express x in terms of y and z, thus having this equation. Hence, the bounds for x over the solid is from 0 to 6 minus 3y minus z all over 3. Now we'll look at the region on the yz plane. So here, this region. The region is bounded by the y and z axis and the line 3y plus 2z equals 6. So this is from the equation of the plane, where since at yz plane, x is equal to 0, so this would be 0. So what is left is the equation 3y plus 2z equals 6 in the yz plane. Integrating now over the region on yz plane, we use the same technique in the previous chapter in getting the area of a region. Since we have considered dy dz as the order of integration, hence we shall use a horizontal strip and obtain first the bounds for y. So the bounds for y in this region is the z-axis, or y equals 0, and the line 3y plus 2z equals 6, rewriting it to y equals 6 minus 2z all over 3. Hence, for the bounds for y, we have from 0 to 6 minus 2z. And lastly, the values for z, as shown in the region, is from 0 to 3. Hence, we have the bounds 0 to 3. Ikaw naman, subukan mo ulit. For the same triple integral, consider this order of integration. That is, we look at the solid this way. So, you first obtain the bounds for z. And as for the plane, since the order of integration is dy dx, hence, you shall use a vertical strip here. Now, you can again pause this video here and try to obtain this alternative answer. Check your answers. Okay, lastly, a triple integral of this form gives us the volume of the solid S. We can write it this way so that we can see that it is just getting a volume by multiplying the area by the height or thickness of the solid. Say we have the rectangular solid as the simplest example, and consider this equivalent of the triple integral. Then, we get the thickness integrating with respect to z and multiply it with the area of the region on the xy plane. Okay, as an example, set up the iterated triple integral that solves for the volume of the solid enclosed by the paraboloids z equals x squared plus y squared and z equals 6 minus x squared minus y squared, where we know that these paraboloids will intersect at z equals 3. To solve for the volume of the solid, you must sketch the graph for you to easily set up the iterated integral. And so you can easily decide the order of integration for which you feel would be easier to solve. So the sketch for the solid is already shown, and with this, the order of integration we should consider is dz, dA. So yung dA natin dito is dx, dy. So you can try dy dx later on. So, with this order of integration, the thickness of the solid is on z. Thus, the bounds for z over the solid is as given. Then, the region on the xy plane is the intersection of the two surfaces, which is z equals 3. So, the equation on the xy plane is given by x squared plus y squared equals 3. And since the order of integration is dx dy, so we will be using the horizontal strip as shown. We write x squared plus y squared equals 3 as x in terms of y. Thus, we have the bounds as shown. So from negative square root of 3 minus y squared to positive square root of 3 minus y squared. And lastly, we have negative square root of 3 to square root of 3 for the values of y. Yan. Ikaw naman ulit. For this example, so you have to set up the iterated triple integral that will solve for the volume of the solid that lies behind the plane, x plus y plus z equals 8, and in front of the region in the yz plane that is bounded by z equals 3/2 square root of y and z equals 3/4 y. So the solid is already given, but you may also try to sketch your own graph for this solid and set up the iterated triple integral to solve for the volume. You may consult your answer with us. Yun lang!
If you want to learn more about topics on Math 28, check out these videos. And don't forget to answer the exercises found in the description below. Have a good day! Bye!